All right, here's our, oh, this is not even labeled right. This is our week 7 review. As you can see, the answers are shown here, so I'm really just going to be explaining where I'm getting some of them from. So here we go. On question 1, we've got 2 lines. Notice you all asked some good questions in class today, so when it has an equal sign, there is no shading or solid or dashed. When it has an equal sign, it's just 2 lines, and where are they crossing? So on question 1, on the first one, I have x equals 4, which is just a line that's going to cut through the x-axis and run vertically. And then I have y equals 3 over 2x minus 4, so that's mx plus b, which means I'm going to start at -4, and then do rise 3, run 2. Make sure to make your pattern go all the way through the graph, and most of you were able to see in class today that these cross right here. Make sure that you actually write where they're crossing, 4, 2, so that you have your final answer. Otherwise, you're doing all the work and never giving me an answer. Question 2, again, we're going to be graphing, and in the end, we should get no solution. Some of you have no solution, but going the other way. So let me show you how we solve these. Remember, because 7 and 4 don't divide in, we're going to need to rework this so that we're in y equals mx plus b. So if I move the 7x over, I have -4y equals -7x minus 16. It becomes -7 because I had to subtract it. Then I'm going to divide everything by -4, which is going to give me y equals, -7 doesn't divide by -4, so that's just +7 over 4x. And then -16 divided by 4 is +4. So I started at 4. And then because I can't go up 7 and to the right 4, I have to go down 7 and to the left 4, which is going to give me this other point. And there's my first line. All right, if you solve the second one, it should be very similar. When you solve the second one, you're going to get, in the end, you're going to get y equals 7 over 4x plus 1. And some of you asked in class today, you were like, well, I don't have enough room to go down 7. You're right, but from last week, most of you remember that my slopes here, because my slopes are the same, these lines are going to be parallel. So all I'm going to do here is just kind of draw the best parallel line I can. And because they aren't intersecting, again, your final answer is going to be no solution. All right, question 3 kind of follows on that really well. It says, which one has no solution? Well, question A, so let me back up. B and C both obviously have a solution because they have different slopes, so they're going to have one solution. The same for C. Notice they're trying to trick you on C because one's positive and one's negative, but both of those are going to be one solution. A and D both have the same slope, so then we have to look at where the lines start. Well, on D, you may notice these are the exact same line, which means D is an example of infinite solutions. So A is going to be my no solution because they have the same slope, but they're starting in different places, so they're going to be parallel lines. All right, for questions 4 all the way through, I think 10 maybe, I can't remember exactly. All of those, you have to pick if it's substitution or elimination. So substitution we did last week, and remember that's anytime you have y equals or x equals. So this first one is an example of substitution. And we plug that in, we're going to get 2x minus 5x minus 9 equals 0. Remember that this minus sign is going to change all the signs in the parentheses. So that's 2x minus 5x plus 9 equals 0. And then we're going to combine like terms since we're on the same side. So negative 3x plus 9. If I subtract the 9 over, because I'm trying to solve for x, I get negative 3x equals negative 9. So x is going to be 3. And then remember, we always have to plug back in to get a y value. And in substitution, it's easiest to plug back in where you circled. So y equals 5 times 3 minus 9, 15 minus 9. So y is going to be 6. And we use those together to write an ordered pair. Now, the biggest thing I want to note to you here, you should always plug these back in to check. So you know it works in the second one because I just plugged it in. But we can even plug this in the first equation and see if it works. So in our calculator, we can type 2 times 3, because that's what I got for x, minus 6, because that's what I got for y, and I'm hoping that my calculator will say 0. And when it does, I know that my answer is correct. So you should always check. There's not a single problem tomorrow that you shouldn't know if you got right or wrong. Question 5 here is an example of something that we would want to do elimination for. And remember, to do elimination, we've got to get these to multiply to be the same number, or actually perfect opposites, so that they cancel. So the easiest thing I think is probably going to be to cancel these 4, or the y's. And to do that, we can multiply the top by 4 and maybe the bottom by -5. So that's going to give me negative 60x minus 20y equals 16, and 60x plus 20y equals negative 20. Now notice this is a weird case because now the x's and the y's both cancel, which gives me 0 on the left side. And then I add everything that's left, so I got negative 4. And here, 0 does not equal negative 4. So when we write our answer, as you can see, they've written the answer to be no solution. You have to say no solution. 0 equals negative 4 is not, that's work. That's not an answer. All right, question 6 here. Again, this is another example of elimination because both of these are in standard form. And it looks to me like the y's might be the things that are easiest to cancel. So I need to multiply the whole top equation by 2. That's going to give me 12x minus 2y equals negative 30. And negative 12x plus 2y equals positive 30. Notice this is a little different than 15 because everything ends up canceling out, which means 0, because you have nothing on the left side, equals 0. And in fact, that's true. That's a true statement. 0 does equal 0, which means this is an example of infinite solutions. Question 7 is another example of substitution. I have an equation that says y equals, so I can plug it in for y. So I have negative 2x plus 7 equals negative 3x plus 7. I'm going to move my x's to the same side, so I'm going to add 2x. 7 equals, I don't know why I did that, negative 1x plus 7. That was annoying. Now I have a negative number. All right, then subtract 7, and that's going to give me 0. Now sometimes, notice they're trying to trick you because they say the answer could be no solution, but because you have an x, there's still going to be an answer. If I divide by negative 1, that gives me x is 0, which right now automatically tells me C is the right answer, but I should always plug back in and check. So if I plug this back in, I could do negative 2 times 0 plus 7 is going to give me 7. Notice that you could also plug this into the top equation. You don't have to plug it in more than once, but you could always plug into the top equation just to check, and notice it gives you the same value for y. So I know that my answer of 0, 7 here is correct. Question 8 is another example of elimination because I'm in standard form. Right here, I actually have something that already eliminates. Here, I'll work in blue. All right, so my y's are going to eliminate. And when I add everything that's left, I get negative 6x equals 30. I'm going to go ahead and solve that out. So x is negative 5. And then you can plug back into either equation. Make sure you're always using an original equation. Plus 5y equals 30. So that's 45 plus 5y equals 30. I'm going to subtract 45 from both sides. So 5y will equal negative 15. And then divide by 5, which means y is going to equal negative 3. And what did I say? What should you always do with your answer? Plug it back in. So use your calculator, plug those back in, and make sure that negative 5, negative 3 gives you what it says it should in each of the equations above. Okay, so if we move on to question 9, notice that question 9 is, again, we're kind of switching back and forth. Question 9 is now an example of substitution because I have an x equals equation. So I'm going to plug this into the x spot. That gives me 4 times 4y plus 13 plus 6y equals negative 14. This is what we did last week. So I'm going to distribute 16y plus 52 plus 6y equals negative 14. Combine like terms, 22y plus 52 equals negative 14. I'm going to move the 52 over by subtracting it. So 22y is going to equal, let's see, negative 66. And then when I divide, that's going to give me y is equal to negative 3. Notice that at this point, you should be able to at least eliminate c, because that does not have y in the correct spot, and d, because it says y is positive 3. So now I just need to plug in to get my x value. So x equals 4 times negative 3 plus 13. That's negative 12 plus 13, which means x is going to equal 1. That's how they're getting A. If we move to question 10 is again going to be an example of elimination. This time they're only asking for the y value, but we're still going to solve the same way. I'm going to multiply my top equation by negative 1. So that's going to give me negative 4x plus 7y equals negative 1. I'm doing that because right now I have close to opposites with the negative 7y and the negative 7y, but I don't have opposites. Those are the same. Now that I do that, I have those that cancel, giving me, if I add everything that's left, 6x equals negative 30. So if I divide, x is going to be negative 5. But remember, I want the y value. Notice that they include negative 5 because they're trying to trick you. I want the y value there, so I'm going to have to plug back in. So 4x minus 7, or I should actually plug the x in. 4 times 5, negative 5, minus 7y equals 1. That's negative 20 minus 7y equals 1. So when I add 20 to both sides, I'm going to get 21. And if I divide by negative 7, that's going to give me y equals negative 3. So that's where they're getting this actual correct answer of y equals negative 3, because they're asking for the y value. Question 11, the correct answer is not completely here. This says select all of the following. So the easiest thing to do is just kind of to try to work with these numbers and see what things cancel. Notice on A, if you multiply by negative and negative, that gives you negative 6x on the top and negative 6x on the bottom. Those are not opposites, so it's not that one. B will give you positive 6x on the top and negative 6x on the bottom. Those are opposites, so that's why B works. C also is going to work. Here they're trying to eliminate the y's. So on C, if you multiply, you're going to get 12y and negative 12y. Those are opposites. And then on D, if you multiply, you're going to get negative 12y and negative 12y, which don't actually cancel. So the two correct answers are going to be B and C. Okay, so if you remember from last week, this is just checking your solution. We have 0 and 4. That means this is 0 is the x value and 4 is the y value. And you're just going to go in and plug those in for each equation. Remember, you need it to work in both equations. So for instance, in the first one, 3 times 0 is 0, plus 4 times 4 is 16. So that gives me 0 plus 16, which is 16, not 0. So it does not work in this first equation. And then obviously, if it doesn't work in the first one, it doesn't work, but you can plug it in the second one and get 0 minus 4, which is negative 4, so it also does not work in the second equation. You need to check all 4 options and each part of all the 4 options until you find the one that it works in. And it should be that you're getting the correct answer is C, but make sure you understand why that is. All right, remember the directions on 13 through 17 say to write, do not solve. So all I have here are the answers for questions 13 through 17. 13 and 14, I think you all are okay on those. Those both have rates in there. The only thing that I haven't done that you should do is say what X and Y stand for. So for example, 14, you would say like X stands for adult tickets, Y stands for student tickets. On question 15, remember that on 15, when you do sum, you have to add the two numbers together. So on question 15 here, I have sum means to add, so x plus y gives you 28, and difference means to subtract, so x minus y equals 3. Question 16 is one that you all are not as much a fan of. So if you want to write, remember if you have 2 variables, you write 2 equations. So if you want to use 2 variables, we can do it like this. Notice that the total of 321 is only in one of the equations. You can't use the total more than one time. So I've used x plus y, the two numbers added together equals 321. And then one of the numbers is twice as large, is y equals 2 times x. Now some of you like the old way, where we have two numbers, two blanks, equal 321. I don't know anything about one of the numbers, so I'll call it x. And the other number, I just know it's twice as large. So the other number is going to be 2x. Some of you, I noticed today, you were trying to write 2y. But remember, if you have two different variables, you have to have two different equations. If you have one variable, like what I've done here in blue, then you only have one equation, and that's all you're going to write. You're not going to write another piece. So just be aware of that for tomorrow. Question 17 we talked about in class. We said that when they told us about nickels and dimes, they secretly told us about rates. And what we mean by that is a nickel is 5 cents each, so we call that 0.05x. A dime is 10 cents each, so we call that 0.1y. And then we have a total of 235. And then because the number of coins has nothing to do with how much they're worth, so the number of coins has nothing to do with any rates, that's just going to be x plus y equals 33. All right, so question 18 here. Remember that anytime we're given a graph, that usually means we're going to be doing inequalities, which means we're going to have to graph. And in fact, question 18 does say that we need to start by writing a system of inequalities. So the first thing I notice is that this problem says that we can spend no more than $1,500. We're purchasing calculators for $90 each, and textbooks are going to be $70 each. So to me, that sounds like standard form. So I'm going to do 90x plus 70y, no more than, that means less than or equal to 1,500. And we want to make sure that we define what x and y stand for. So x is for the number of calculators, and y looks like it's going to be for the number of textbooks. And then we also have this additional value that says that we need to buy at least 10 items. So if I want to buy at least 10 items, items alone just means the solitary variable. So that's x plus y is at least, which is greater than or equal to 10. So to graph these, remember we're going to split into intercepts. So if I take this first equation, that means I'm going to get, if I can get my pen working. On this first equation, I'm going to get 90x equals 1500. And then we're going to divide to get our intercept. So on that one, I got my intercept to be, I have 16.6 repeating. And then on the other one, 70y equals 1500. This is exactly what we did last week. And we actually did this earlier this week too. So on this intercept, I'm getting 21.4. So we're just going to estimate when we're graphing, get as close as we can get. So 16, a little over 16, a little over 21. And in this symbol, less than or equal to means I'm going to have a solid line. And I want to be shading less than, so I'm going to be shading below. And then for my second equation, the intercepts on this second equation I have written in blue is a whole lot simpler. My intercepts there are just going to be 10 and 10 for x and for y. So if I go ahead and plot those then, 10 on the x-axis and on the y-axis. All right, we want to connect those. This time it says greater than or equal to, so I'm going to shade greater than or equal to. And remember, our solution set is this overlapping shaded area in between here. So so this problem says name one solution and one non-solution. We want to make sure that we've labeled our each axis. So when you name your solution, for instance, a solution in this shaded area could be like 8-4. You want to say like so many calculators and so many textbooks, the same way we write a sentence normally. Don't just give me an ordered pair. I want you to give me some context with that, so make sure you use units. All right, question 19. Remember, you need to go ahead and graph these. And on question 19, we're selecting all that are solutions. Solutions are in the double shaded area and on the solid line. Things on the dashed line are not solutions. So my answers here are 2, 0, 1, 1, and 2, -1. The one that people are usually most confused about are positive 1, which is this point right here. But because this point is on a dashed line, like I know it's on a solid line, but remember it's got to be for both. So because it's on a dashed line, that means that one does not count. All right, if we move over to question 20, we're supposed to be writing a system. So this first equation, they're getting that because you're starting at 0 and you have a slope of -2 over 1. It's solid and you're shading above, so we're going to do greater than or equal to. On our other line, this is just a vertical line that's only cutting through the x-axis at 1, so that's why I have the x and the 1. And we're shading to the right, and it's dashed, so that's going to be greater than there. You really need to know your greater than, solid, and dashed rules for this test, so make sure you review those if you need to. Question 21. Remember, you should recognize that these are going to be parallel, but we always have to do the shading to know where the solution is. So on the first one, on this top equation, I started at +2, down 3 over 2. I have a solid line, and because it's less than, I'm shading below. So for this one, you actually would probably maybe have all of this shaded in. And then for our second line, we're going to start at -2, do the same slope. This time it's going to be a dashed line, and we're going to shade below. So notice they're only shading the final answer. You can shade everything. I don't care if you shade both of them as long as you make it very clear where is the solution area, which is the double shaded portion. 22 is very similar. On the first part though, some of you I think are going to get tripped up on this. You can find your two intercepts. The x is going to be at -1 if we cover up. The y is going to be at +1. And remember, because y is negative, like the sign in front of the y is negative, it's actually going to flip my symbol around. So that's going to give me y is less than, which means I need to do dashed, and I need to do below this time. So that's why this line is going to be shaded below. And then my y line, y is less than or equal to 2, so that's going to cut through the y-axis at 2 and be solid. And less than means I'm going to shade below. And notice what they're putting in red as the final answer is that double shaded portion. So your area should just be darker if you're going to shade everything. I actually recommend you shade everything because it's a little bit easier to do it that way. All right, so if you need help or have any questions, make sure you come to tutoring in the morning. Make sure you've studied all of these things so that you're ready for your test tomorrow.